So for this problem, they give us that spring 2 is stretched 0.5 feet. So I might start in this system right here because that's where spring 2 is. So let's just go through our unknowns here and see if we can solve this FBD here based at G. Well, we're going to have GH is going to be an unknown tension, TGH. We're going to have a force going this way, that's unknown, and that's basically going to be the spring force from the equivalent spring, which represents these three springs. So that's a second unknown. And we have this force right here in spring 2. We're going to be able to figure out what that is because we know it's stretched 0.5. So let's write that out real quick. So the force in spring 2 will equal its K value, that's 100 pounds per foot, times its stretch, which is going to be 0.5. So that's going to be 50 pounds. So we actually do know this force right here, 50 pounds. And you remember that springs in series have the exact same force. And we can prove that really quickly. If you zoom into this little purple point right here and do a quick free body diagram on it, what two forces do we have acting? We have spring 2 going up at 50 and this unknown spring going down. Well, those are the only two forces. So therefore, this has to be 50 as well. Spring 1. Simple as that. So spring 1 has 50 pounds. And since we also know the stiffness of spring 1, we can figure out the deformation. That will be 0.25 feet. Alright, and further going down here, let's see if we can figure anything else out. We can do an FBD on that weight 2 right there. I mean, we only know there's only two things touching it. There's the spring 1 going up at 50, and there's the unknown weight force going down. The weight 2 has to be 50 from here. 50 pounds. So there, we just knocked out a couple of answers there. We know the displacement of spring 1 and the weight 2. And in a quick second, we can figure out C, the equivalent spring constant for springs 1 and 2. Let's just do that right now. So we know the equation to simplify springs in series to one big equivalent spring, which represents the ones in series. So we can just plug in our values here. We have K1 as 200 pounds per foot and K2 as 100. We can just crunch the math here. And it's 66.67 pounds per feet. So we just knocked out a couple of answers right there. So just by looking at spring 2, we were able to get 3 answers. Now, looking at G again, we have one unknown, that's GH. The second unknown, this whole spring system over here. Now the third unknown is going to be this tension going to the left, right here. So that's too many unknowns here. For a free body diagram for a point, sum of the forces x, sum of the forces y, we only have 2 equations, and that can only handle 2 unknowns, but we have 3 unknowns, which means we've done all we can here. We should move on to another system and see what we can do. Maybe we might try looking at this weight right here. We do know the weight, but we have these 3 different ropes here. And we are only really allowed to have 1 unknown here because we basically only are able to do some of the forces in the y for this 110 pound mass right here, or weight. So maybe we'll look at the whole pulley system and work through that. Let's start over here and let's work through the pulleys, and we'll call this rope tension T. Okay, so this rope kind of goes through this pulley right here, so this is all T here. And then we reach this pulley. So we do a quick free body diagram on that pulley B. We know we have one of those rope T's and then another of those rope T's. So we have two T's going up, an unknown force going down, and this pulley has no weight, so we don't have to draw in a fourth force. So therefore, this question mark must equal 2T. Okay. So this is 2T, 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 2T here, so 2T and 2T. Another quick FBD at that pulley C right here. We have the rope that has 2T in it coming in and going up. So we have two of those 2T's going up. We have an unknown going down. Therefore, the unknown must equal 4T. That is going to be the force in that rope right there. So this rope right here, 4T. Alright, that's good because that's one of the ropes, attaching to our weight there. Okay. We know this guy's 2T. We've already talked about that. 2T, 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 and here's 2T. Actually, no, that was just T. This is still T right here. Alright, so looking at pulley E, and we have T going up, we actually have this one singular rope coming across the top. So those are two unknowns going down. And this is the same rope here, so these two unknowns are the same tension, the same rope. And therefore that must equal T over 2. So this rope here is activated with the tension of T over 2. So T over 2. And lastly, at that pulley F, that T over 2 rope comes down, loops around, goes back up. So there are two of those T over 2 ropes pulling the pulley up, and we have one unknown going down, therefore that unknown must be T. So this last rope touching the block is T. And like we said a second ago, that rope, this one right here, extending over to the right to our G system, that is T over 2. So we take a look at that block, quick FBD on that, 110 pounds going down. We have 4T going up, the rope on the left. The rope in the middle is T over 2, and the rope on the right is T. So of course we can add up the forces in the Y. So we have 4T, it's positive going up, plus T over 2, positive going up, plus T going up, 1,100 going down, all equal to 0. And we can solve for the value of T. And we get T as 200 pounds. Knowing T is great because we can basically figure out the weight here. We have the force of gravity, weight 1 going down. We have T going up. Of course, T we know to be 200 pounds. We don't even have to write out the math for that. We know for there to be balance, that weight force must be 200 as well. So there is our answer for A. So now we can go back to the system based off of G. We know that this rope right here has a force of T over 2. And T we learned is 200, which means this force is half of it, 100. We know the spring force here, 50 pounds. So we have an unknown force, GH here, and then an unknown force here from this whole equivalent spring system here. So, two unknowns, we can handle this system. So, before we draw the free body diagram, let's just simplify this system of parallel springs right here. These are clearly springs in parallel, and we know we can just add their stiffnesses up. So K3, 300, K4, 400, K5, 500. Therefore, that's going to be 700 plus 500. That's going to be 1,200 pound-feet right there. So let's simplify our free body diagram here. So here's our simplified free body diagram. Our only unknowns are this TGH here and the X, the stretch of that equivalent spring system. We know that the stiffness is 1,200. So we can write out the sum forces Y and sum forces X equations for this system. We only have two unknowns. And we'll be able to calculate some answers here, TGH and X. So adding up the forces in the X, we have a negative 100 from that T over 2 to the left. We have the positive X component of TGH. And we have that whole equivalent spring pulling to the right. So that'll be a positive. All added up and equaled to 0. Two unknowns in this one equation, so we can't solve anything right now. Let's go to sum forces in the Y. We have a 50 going downwards from our spring 2 that we figured out in the beginning. We have the upwards component of GH, and that is that. So from the sum forces Y equation, we only have one unknown, so we can solve for it. So TGH, if you do that math, will equal 100 pounds. And with that 100 pounds, you can plug that right in for TGH in our sum forces X equation, and we can figure out the stretch of that 345 equivalent spring. And we'll get 0.0112 feet. So we've got our force in GH, we've got our amount of deformation in spring 3, so that's G. We still need the force in the equivalent spring. Well, the force in the equivalent spring is really this quantity right here. It's the K, which is the 1,200, times the compression, the X, which is that 0.0112. Multiply those out, we get 13.4 pounds. And that is it.